Let's look at example 38.1 and lesson 38. It says expand x plus 3 cubed. Well, this is probably exactly what you think it is. Well, maybe not. I'll tell you what it does not mean first. X plus 3 cubed does not mean to distribute the 3 to each and say x cubed plus 9. That is not what it means. What you have to actually do, the cubed, well, let me say this. The x plus 3 is its own identity. So therefore, what you have to do when it says cubed is you have to write x plus 3 times x plus 3 times x plus 3. In the past, you may have had x plus 2 squared, and that was x plus 2 times x plus 2. That's what you had to do, or whatever, whatever it was squared. But you have to actually square the identity. And so from here, I would look at the first two, and we do FOIL. Remember first? Let me write it this way. FOIL. First, outside, inside, last. Okay? So what are the first ones within these two? Ignore this right now. First one in each parentheses is the x. So we multiply x times x and get x squared. So we got the first. Then we got to do the outside. Okay? Outside is the furthest away from each other. So x times 3, that would be 3x. So we did that. Now we got to do the inside. Also 3x, and then last 3 times 3, 9. Get to this point, we can go ahead and simplify to plus the 3x's to be plus 6x. Then we move this down. I'm going to move this right here because I like the little one, the shorter one first. I like the 2 in front of the 3. And from here, you multiply everything by everything. So I'm going to multiply this x by the x squared, 6x, and 9. That will be x times x squared is x cubed. X times 6x is plus 6x squared. X times 9 plus 9x. Now we got to do the other one. Got to do 3. 3 times x squared, 3x squared, plus 18x. 3 times 9 plus 27. Now we find like terms. Are there any other x cubes? No, so I'll bring that down. Are there any other x squareds? Yes. 6 and 3 add up to be 9. Then tag along the x squared. Are there any more x's? We got 9 and 18. So 9 and 18, 27. Bring along the x plus that 27. So that would be your answer, and that is how you expand. It's a pretty long answer, but really not difficult math. You just got to make sure when you do x plus 3 cubed, you multiply x plus 3 times itself 3 times. Now let's look at solving by factoring. What we've had in the past is something like x squared minus x minus 6. And that's all we have. Oh, I wrote that a little high. Now we actually have an equal sign. This is what we've had in the past, but now the difference here is the equal sign. When you have an equal sign, you can actually solve for x. So the first thing I want to do is I want to rearrange it just like so. X squared, x, no x. So I'm going to move this here. X squared minus x equals 6. We need this 6 on this side. How can we do that? Well, we subtract it. Well, if we're subtracting 6 from this side, what are we left with over here? 0. So now we have x squared minus x minus 6 equals 0. And now we can factor right here. So what multiplies to be negative 3 and adds up to be negative 1? x minus 3, x plus 2. Now those equal 0. Now we're at this point. From here, what we do is we isolate each identity, or each sum, and we make them equal to 0. So I'm going to say x minus 3 equals 0. And then I'm going to say x plus 2 equals 0. So we separate each one to say they equal 0. So when we solve for x here, we would add the 3. And we would get x equals 3. And then when you subtract the 2, you get x equals negative 2. So you actually have two answers. 3 and negative 2 would be your answers. And if you wanted to, you could plug them back in and check it. You know, I'm not going to do that, but you could plug them even right here. 3 times 3 is 9, minus 3 is 6, minus 6, 0. That one works. Negative 2 would go in parentheses squared. So that'd be positive 4 minus negative 2 is a positive 6, minus 6, 0. So it would work out, but you're always welcome to check it. Let's look at another example here, one with a little more to it. Negative 35x equals negative 2x squared minus x cubed. First thing we want to do is get everything on the same side. Now I'll say this, I like, this is the biggest amount in the exponent, so I want this one to be positive. So I'm going to actually move both of these to this side. So I'm going to add x cubed. I'm going to add 2x squared and get x cubed plus 2x squared minus 35x. And what does it equal? 0, because there's nothing on that side anymore. From here, when we factor, they all have an x, so we can do a little factoring before we do the double parentheses factoring. We can take the x out and be left with x squared plus 2x minus 35. That'll equal 0. We factor this, what multiplies to be negative 35, but adds up to be positive 2. What two numbers? And they will be a factor of 35, just FYI. And it would be x minus 5, x plus 7. Don't forget about this guy. And so now we have it factored. Now the difference here is we have this x. This is the only difference from the last problem. We have this x. What we do is we say x is equal to 0, x minus 5 is equal to 0, x plus 7 equal to 0. So this is actually an answer for x. So x equals 0. When you add the 5 to the other side, you get 5. Subtract the 7 and negative 7. And those would be your answer for x. And that's how you solve by factoring. If you have an equal sign, you actually are solving for x. If you don't, then you're just factoring. I'm going to show you one more here. The book wanted to make sure that you know that only 0, well, I'll explain it in the end. If I was solving this, what I want to do, something I could do is factor out the 2. Because 2 goes into 2, 2 goes into 4, and 2 goes into negative 70. They're all divisible by 2. So I could say 2, open parentheses, x squared, 4 divided by 2. This would become 2x. It would become negative 35 equals 0. Then we'd factor this like we did before. X plus 7, x minus 5. We already know that these, we can say, are equal to 0. But the whole point of me doing this is, in the last problem, this was an x. So we could say x is equal to 0. So if we said 2 is equal to 0, well, that makes no sense. That's not true. So 2 is not equal to 0. So therefore, this problem would only have these two answers. It would be negative 7 when you subtract the 7 to this side, and positive 5. So the book just wanted me to make sure I taught that. Just to know that 2 doesn't equal 0. Sounds like common sense, but don't put that 2 or anything as an answer. You would only have 2 answers here. Anyways, that is how you do solving by factoring, and that concludes lesson 38.